Ladies and gentlemen, the audience of the 4th International Conference of Applied Science and Technology, it is a pleasure for me to participate in this great event and address such a great audiences. Allow me, Teresia Evila Purwanti Sri Rahayu, to present result of my research with the title of Utilization of bottom S and biogas sludge into carbon briquette as an alternative fuel. This research conducted in consideration that bottom S as byproduct of coal power plant gain less attention to be utilized compared to fly ash, despite the fact that the amount of bottom ash keep increasing due to increasing of electricity production in coal power plant, especially in Indonesia, where most of its power plants are still using coal as its fuel. For this reason, study of bottom ash are worth to conduct in search of effective management and potential utilization. This study also involved utilization of biogas residue for similar reason that it is gain less attention to be utilized compared to biogas, which are well known as promising future energy source due to its economical, renewable and clean energy characteristic with high calorific value. State of the art. Former research of bottom ash commonly propose its utilization as fertilizer and soil amendment, but it can be utilized as household fuel or gasifier feed after briquetting or pelletizing, according to James et al. 2012. While according to Campo et al. 2010, in his research on fish farm sludge, it can be used as agricultural fertilizer, input factor in microalgae production, source of combustion, and fish feed ingredients. Many researches also have been conducted by scientists on utilization of wastewater treatment plant sludge as alternative energy source such as industrial fuel or combustion feed for incineration. And this research aimed to investigate potential utilization of bottom ash as fuel by mixing it with carbonized biogas sludge using briquetting method as part of larger purpose of finding effective and efficient method to optimally utilize bottom ash. This research used materials of 1. Bottom ash, which was taken from Bunton Coal Power Plant Adipala, Cilacap, Central Java. 2. Biogas sludge from anaerobic digestion of mixture of cow manure, fish waste, and water hyacinth with ratio of weight 5:1:1. Cow manure, fish waste, and water hyacinth originally taken from around coastal area of Cilacap, Central Java. And commercial sugarcane molasses used as mixture binder in carbon briquetting process. This experimental method can be described as follows, as you can see in this diagram. First is the anaerobic digestion of mixture of cow manure, fish waste, and water hyacinth with weight ratio 5:1:1 for 28 days. After 28 days, sludge collected. Then it is dried up under sunlight exposure for 5 days prior to carbonization with temperature of 200 to 300 degrees Celsius for 2 hours to produce biogas sludge carbon or BSC. Bottom S or BA then added up to this carbon to form carbon mixture. Molasses then added to this carbon mixture with ratio of solid to molasses in weight ratio 1 to 1.25 to bind the solid and make carbon briquette, but this briquette is still wet, so it is dried up under sunlight exposure for 5 hours before analyze. The analysis taken in this research are first moisture content analysis by heating the briquette at temperature 105 degrees Celsius until the weight is constant. Second, as content by heating the briquette at temperature of 550 degrees Celsius for 3 hours. And third, calorific value analysis using bomb calorimeter. The results are provided in Table B. We write percentage of BSC and BA compose the briquette into 6 variants, as you can see in Table B. Moisture content, as content, and calorific value of experimental briquette compared to those of Indonesian quality standard for briquette provided in Table A. Analysis of moisture content. From the graph, we know that moisture content of briquette increased along with the increasing ratio of biogas sludge to bottom ash. This is due to hygroscopic nature of biogas sludge. But high moisture content is a disadvantage in capturing energy of fuel briquette because it inhibits conversion of chemical potential energy into heat by oxidation process or combustion. From this graph, we also know that all the variants of briquettes are below limit value of standard or below 8%, which meet the requirement of Indonesian quality standard for briquette. Second, or number 2, as content analysis. From the graph, we may conclude that increasing ratio of biogas sludge to bottom S decrease as content of briquette. This is due to the amount of bottom S composed the briquette. The S content prevent combustion gas-free movement to the core of briquette, and it will inhibit energy conversion, which is unwanted. This is according to James et al. 2012. Number 3, calorific value analysis. From the graph, we know that calorific value increased with the increasing ratio of biogas sludge carbon from only 270.9141 calorie per gram for 100% bottom ash to as high as 2100 180.7976 calorie per gram for 20% of bottom S. The highest calorific value of 20% bottom S, still below Indonesian quality standard for briquette. So the conclusion of this research is that briquette carbon has its highest calorific value of 2180.7976 calorie per gram for 20% bottom S briquette with 48.79% of S content and 5.7% moisture content. This calorific value and S content are still not meet SNE or Indonesian quality standard for briquette. However, it might open ways for future research of bottom ash utilization, that it's not just ended at landfill, but it still needs further research to be optimally utilized as fuel. This is my presentation, which is still far from perfect, and for that, we are open to advices for our improvement. Thank you.